Okay, so then there's the problems where it's like find all the sets of three consecutive odd integers whose sum is between 20 and 30. So I'm getting that right from your book. All right, so once again, I'll write that down, at least some notes here. We're finding all sets of three consecutive odd integers, and it's such that the sum is between 20 and 30. Okay, so how do you do that? Well, first of all, definitely recognize that we're dealing with the sum of all three consecutive odd integers. There are three consecutive odd integers, and as you've learned, it's a good idea to represent the middle one as an x, and then the next one down the line would be the x plus 2. And then the other one, we're almost like swinging around in the other direction, and it's x minus 2. Okay, so we could use these as our representation of three consecutive odd integers. Now what we're dealing with specifically is the sum of these consecutive odd integers. Okay, and more specifically, what we're dealing with is the sum of consecutive odd integers that are between 20 and 30. Now, as you can see, this inequality is these inequalities are facing in the same direction, and whenever you have that and you have some like a variable or a group of variables like between those two inequalities, that value of this sum is literally between these two extremes. Okay, now you could go ahead and just solve this, and I'm a big fan of saving time, so I'm going to just not divide this up into two different equations. I'm going to kind of keep it in this like weird triple situation. And the first step would be to just simplify this thing in the middle. That ends up being 3x, as you know. You're pretty well practiced at that by now. So we end up with 3x is less than 30, and 3x is more than 20. Good, and then from there, dividing everything by 3 would give us x in the middle. We'd have 10 over here, and we'd have 20 over 3 over here. I have a suspicion that your test is probably going to have it like that, where you're going to have at least one of them be an improper fraction, and then you're going to have to go ahead and convert that to a mixed number. So I'd say let's do it right now. That would be 6 and 2/3, and you seemed pretty good at that. In fact, this might even be the exact same problem that we did earlier today, but whatever. It's a reminder. So we have 6 and 2/3 is less than x, and x is less than 10. Okay. Obviously, it's a good idea to convert this thing to a mixed number because it makes it easier to graph on a number line. Because honestly, who knows? I mean, who knows off the bat what 20 over 3 is on a number line? That's weird. Alright, so we have 6 and 2/3 is less than x, and x is less than 10. Great. Alright, now, at that point, I'd say it's at that point that I would recommend making the that table where we have x plus 2, and we have the x minus 3. Okay, so, or x minus 2 rather. And we have these three columns. And what's going to go in the rows are all the various sets that would apply. Now, focusing only on the x column, because that corresponds here. Okay, so this is the x column corresponding with this thing. Now, x is all the odd integers between 6 and 2/3 and 10. Well, what is that? That would be, and I'm going to do it in red, I'll keep it in red. That would be 7, that would be 9, and guess what? That's all there is to it. And then the rest is pretty easy to fill out, you know. 7 plus 2, 9. 7 minus 2, 5. Okay, we have this 9 here, right here. 9 plus 2, 11. 9 minus 2, 7. So these right here are the sets of numbers that when you add them up, the sum would be between 20 and 30. If you were to add these up, the sum would be between 20 and 30. And you could always double check. It definitely works for sure. Okay, the sum of these is definitely more than 20, and the sum of these is definitely less than 30 for sure. Alright, so that's how to do that. These are all the sets. Okay, so every consecutive odd or whatever where it's between two extremes, I believe it's safe to assume that this exact method will apply. Okay?